Hi, it's Mrs. Ramsey, and I'm so happy that we're together for a math video. All right, let's look at our 3.1 notes video, learning objective. For this lesson, we are going to focus on learning using integers and absolute value to order on a number line, and we're going to learn how to evaluate an expression. The graphics that we're going to be using is the number line that you can see. And not only when it's given to us, but also being able to graph on a blank number line. So reading a number line and also graphing on a number line are skills that we're going to work on in this lesson. And then I'm going to just show you the math sign that we're going to use for absolute value. Okay, these two up and down lines, we're going to be using those and learning how to use them correctly. Let's get started. Look at the top of the screen with me, please, at the stop sign and the pencil. These are the symbols that I will use when I want you to copy notes and fill out your video notes assignment that you turn in to me. Our first words to learn is integers. An integer is any number from this set. And there's a lot of numbers that are listed here. These dots just mean that we could list numbers that come before -4, and we could also continue this pattern and we could list numbers beyond +4. So I have two boxes here that I want us to fill in right now with examples of integers, but also examples that are not integers. Well, in our definition, we're given examples of integers, so we know that -4 is an integer. We could jump up to -1, and that's an example. What about +2 or 0? Any of those numbers are integers. So what's a number that is not found in that list? What's not an integer? Fractions. Fractions are not integers. So 1/2 is not an integer, even if it's negative -2/3. Fractions, whether they're positive or negative, are not integers. What's another type of number that we don't see in our definition? Percent. A percent is not an integer. I'll write down 15%. Maybe you write down your favorite number, okay? Any percent is not an integer. There's one other type of rational number that is not an integer. Decimal. Decimals are not integers. So I'm going to write 7 8/10. Any decimal is not an integer. All right, let's move on to positive integers and negative integers. Well, this is where the graph really helps because we start to organize numbers compared to 0 here. And 0 is kind of a special number. It's really not considered a positive or a negative integer, but it does separate our positives from our negatives. So positive numbers are any integer that is greater than 0, and negative numbers are numbers that are less than 0. And then we have absolute value. We're going to be using this to help us put numbers in order. And later on in this chapter, absolute value is going to be really helpful when we're adding and subtracting with negatives. It's numbers that are the same distance from 0 on a number line. All right, let's move on. Absolute value. The definition of absolute value is the distance a number is from 0. And 0 is circled on our graph because it's a marker. We want to be able to visualize the distance that any number is from 0. So let's start with an example. What if we had +3? And we wanted to find the absolute value of +3. Well, we have to start with using the absolute value sign, which is these two straight up and down lines. That's the sign for absolute value. And then we would just write 3 inside. So when we see something like that, what we would say out loud is the absolute value of 3. And we can even mark on our graph just by drawing a line. That's the distance 3 is from 0. And that's something that we could definitely count separately, 1, 2, 3. And our answer is 3. We can also find the absolute value for any negative integer. So let's take -5, for example. So we're going to start by writing our absolute value sign, those two straight lines, and we're going to write -5 inside of that. And the question is, what is the absolute value of -5? We can even draw on a graph just to help us visualize what is the distance of -5 from 0. And our answer is 5. And I want you to notice that with absolute value, it doesn't matter if it's a negative number that we are finding the absolute value of. Our distance from 0 is always going to be written as a positive number because distance really isn't seen as a negative, it's a positive. I will be practicing that. Now that we've been introduced to absolute value, we can evaluate an expression. But this word evaluate always seems confusing to me because I have a hard time visualizing that in my head. What does that mean? This might help you. There's another math word that we use a lot, and that is to simplify. And that's what evaluate means. And if you're simplifying something, you're going to take lots of numbers and end up with a one number answer. So let's look at this first example. We have these two up and down straight lines, which of course that's not what we're going to call it. We're going to call it the absolute value of -5. Now we've added an operation, we're going to add, and we have another number. The first step before simplifying is always to rewrite the absolute value of this number. And rewriting it is asking yourself, what is the distance that -5 is from 0? And our answer is 5. And now we can copy the plus and the 2, and here's where we get to simplify. 7. So our final answer is 7. We've simplified. We have not changed the value of our expression. We have just rewritten it, and we have a one number answer. All right, let's take a look at the next example. We have 12 minus the absolute value of 4. Well, I'm just going to start by writing the 12 and copying the minus sign. Okay, absolute value of 4. What is the distance that 4 is from 0? And our answer is 4. And 12 take away 4 equals 8. We're having fun, and we have reached the last part of our lesson before we try it on our own. Order integers. We've been given a set of numbers, -2, 3, 0, -5, and we have a blank number line, which means we're going to have to graph our numbers, but also put them in the correct order from least to greatest. I always think it's easiest to graph the 0 first, and that's been given to us because 0 is a marker. It divides the positive numbers that on a horizontal number line are moving to the right, and then those negative numbers are on the left of 0. +3, you can put your tick mark anywhere you'd want, and then you can label it. That's the only positive number that we have in our set. So that leaves us comparing two negative numbers. Now, when it comes to numbers, we always think that the bigger the digit, the bigger the number. But that's not how it works with negatives. So I wrote that out. With negative numbers, we have to remember that as the digit gets bigger, the number is actually getting smaller. So this is where absolute value can also help us to visualize where we should graph a number. -2. All right, let's think absolute value. -2 is two values away from 0. So this would be -1, right? Here's -2. Let's graph it. Now we have to keep going. -3, -4. Oh, here's where -5 is. So even though 5 is a bigger digit, it's actually smaller or has a lesser value than -2. Okay, here's our try it with our pencil. I encourage you to pause the video and work through these 4 problems on your own and then play to check your answers. Okay, now you can check your answers. For this one, I just wanted to point out, you don't have to mark the 0. I just like to do that because, again, it helps to divide the positive numbers from the negative numbers. And we've got our solutions. All right, great job.